Hello. In this video, we'll talk about drawing linear graphs. Our goal for this lesson is to correctly draw the graph of a linear equation. In this case, we will use methods of drawing a table and assigning arbitrary values for x and solving for y to get points to draw our line. I will use a paper from Corbetts Maths to guide us so that we can work on examples. Now, take note that a linear equation will always give you a straight line graph. So that's one thing that you need to remember. When you're given a linear equation, automatically the graph that you expect will be a straight line. Also, remember that you would need at least 2 points. Let me just write that down. So at the least, you just need 2 points. So if you're working on an equation, you just need to get 2 points from that equation to make a line. So just connect 2 points and then you end up with the line. But in some equations or some examples that we have, in this video, we will be looking for more than 2 equations, just more than 2 points, just to make sure that we end up with a linear plot. So let's look at the first example, and this gives us like a specific situation that we can easily draw a graph of. So on the grid, draw the graph of x equals 3. Now, this is very important. So if you see a linear equation that tells you that x equals 3, or any value of a number, and the equation goes x equals n, okay, x equals n, where n is any number, positive or negative, you would automatically look at a point on the x-axis, in this case the positive x-axis because this is positive 3, okay, and draw a vertical line through that point in the x-axis. I may find it hard to draw a straight line, but I will try my best. So we are expecting a line that goes a vertical line. We say that this is x equals 3. That means for any other values of y, in this case, we always have the same value for x, which is 3. That's why it's a vertical line. Okay, so this always produces a vertical line. X equals n, always a vertical line. Now for the next example, we have on the grid, draw the graph of y equals 1. So in this case, we say that for any other values of x, y is always equal to positive 1. Okay, and so that's the equation that we're working on. And so if we have a situation wherein y is equal to n, we say if x equals n is always a vertical line, this one is always a horizontal line. So you have to look at y equals 1 and draw a horizontal line through that. So that's y equals 1. Okay, and we say that this graph is y equals 1. So again, if you have an equation of the form x equals n, then that's a vertical line. If it's y equals n, then that's a horizontal line depending on the value of n. It could be positive. So if it's a positive number, x equals n is a positive number, then it will be on the positive x-axis. If x is equal to negative number, then you would draw the vertical line on the negative x-axis, and the same with y. Now, according to letter C, write down the coordinates of where the points, where the two lines meet. So we're looking for the coordinates of the intersection. Okay, so that's the point of intersection, and we say obviously that would be 3 and 1. Now remember that when you're drawing your ordered pairs, okay, or ordered pair, remember that the value of x goes first, and then the second digit is the coordinates on y-axis. So that's how you draw linear plots or linear graphs when you have equations of the form x equals n or y equals n. Feel free to pause the video so you can take down notes. Now let's proceed to a more complicated equation, but it's not that going to be that hard, so don't panic. So we have the equation y equals 2x plus 4, okay? And we are given a table of values of x and y. We have values of x, -1, 0, 1, 2, 3. And we have the values of y. For x equals 0, it's 4. And x equals 3, it's 10. So how did they come up with these values? So let's look at this. X equals 3, y equals 10. All you need to do is plug in the value of x to get the corresponding value of y. So in this case, the equation is y equals 2x plus 4. And we say that in this case, according to this, x is equal to 3. So we replace x with 3, or we substitute 3 to the value of x there. So it's going to be y equals 2 times 3 plus 4, which is 6 plus 4, which is equals 10. Hence, we get the value of 10 in that column in our table. Now, this is the same procedure that you will follow to solve for the other missing values of y. So let me write it here. For x equals -1, so equation is y equals 2x plus 4. So if x is -1, this is going to be 2 times -1 plus 4. So it's -2 plus 4. It's +2. Okay. For the next one, for x equals 1, y equals 2 times 1 plus 4. So it's 2 plus 4. That's +6. And then I'll write it here. For x equals 2, y equals 2x plus 4. Replace x with 2. So 2 times 2 plus 4. 4 plus 4 equals 8. So now that we have completed our table, okay, we can proceed to the next part, which is drawing the graph. Again, I told you earlier that you just need 2 points to draw the graph. Okay, however, because you were asked to solve for those different points, you can just use all those points to make sure that you end up with the line graph. Okay, so let's look at -1 and 2. So -1 and 2 will be -1 and 2. So this one here. Okay. And then we have, so let me label that, -1 and 2. Next point is 0 and 4. 0 on the x, 4 on the y. And we have 1 and 6. 1 and 6. 2 and 8. 3 and 10. As you can see, they all line up to trace a straight line. I will try my best to make this a straight line. Okay, so that is the graph of the equation y equals 2x plus 4. And so, as you can see, we would have been able to draw a line by just using -1 and 2 and 3 and 10. But we were asked to solve for all those points, so we better off use all those points. Okay. Let's look for something. Here you go, something with a fraction in it. Okay. So in this case, we should not be stressed or scared about this because fractions are just numbers, okay? And since most cases, you will be allowed a calculator. And if you think about it, 1/2 of x is just dividing whatever the value of x is by 2. So just half the value of x. So we were given the x values here, 0, 1, 2, 3, 4. So we would have to solve for the different values of y, okay? So if x is equal to 0, what is y? So x over 2, or 1/2 x, plus 1. If x is 0, then this is 0 plus 1. And so 1, excuse me, 1, when x is 0, y is equal to 1. Let's go to the next one. Y equals 1 half times 1 plus 1. That's 0.5 plus 1, 1.5. So when x is equal to 1, y is equal to 1.5. Y is equal to 1 half times 2 plus 1. That's 1 plus 1, and that's 2. So when x is equal to 2, y is also equal to 2. Y is equal to 1 half times 3 plus 1. That's 1.5 plus 1, so that's 2.5. So when x is equal to 3, y is equal to 2.5. And then for the last point, y is equal to 1 half times 4 plus 1. So that's 2 plus 1, that's 3. And so the last number there is 3. Okay, now we will draw on the grid the graph of y equals 1 half x plus 1. So we just plot the points based on what we're given. So x equals to 0, y equals 1. That would be this one. X equals 0, y equals 1. X equals 1, y is 1.5. So midway, 2 is 2. 3 is 2.5. 4, 3. And as you can see, it traces a straight line. So you just, and there you go. Now, a very important point here to see here, that is where the line intersects the y-axis. We call this point, the name of the point is 0 and 1. We call this the y-intercept of the graph. Let me write that down. Y-intercept of the line. It's defined as the point at which a graph intersects the y-axis. Okay, so wherever the graph crosses the y-axis, that point is called your y-intercept. Feel free to pause the video so you can copy notes. And so the rest of the examples are going to be like that. So you don't need to worry about it too much. Let's work on question 13 here, where we're given an equation without a table. And so we would have to draw the table ourselves. Okay, you probably encountered questions like this on Maths Watch or any of the other examples that I gave you or work that I gave you. So this is the same technique that you need to use. So just draw a table, assign any numbers for x. Okay, so easiest if I draw the table first, something like this. Okay, so x, y. Let's just try 3 values, shall we? So let's go from 0, 1, and 2. Okay, and so I just assigned that. I chose those numbers for x because I can choose any numbers. Okay, I would just work on numbers that are easy to process and substitute in my equation. So if x is 0, what would be the value of y? This is our equation. Y equals 4x minus 2. And you can see there straight away that y is going to be negative 2 because it will be 4 times 0, which is 0. 0 minus 2 is negative 2. Okay. The next one, if x is equal to 1, so y is equal to 4 times 1 minus 2, it's going to be 4 minus 2, so y is going to be 2. So what goes here is the number 2. Oops, change color. Sorry. Okay, and then for the last one, if y is equal to 2, x is equal to 2, so it's going to be 4 times 2 minus 2. It's going to be 8 minus 2. It's going to be 6. Okay, and so what goes here is 6. And so we have 3 points here. We have 0 and negative 2, 1 and 2, 2 and 6. And all we need to do now is plot those points in our grid. So 0 and negative 2 is basically our y-intercept. So it's going to be here. Okay, that's 0 and -2. Next, 1 and 2. 1 and 2 is here. And then we have 2 and 6. 2 and 6 is here. Again, you can use more than 3 points if you want, but this solves our problem. We actually have more than enough. We just need 2 points, but we just want to make sure, so we use 3 points. And so we connect. I hope I can connect them properly. I missed a little bit, but that's okay. So this is the graph of the equation y equals 4x minus 2. I hope you learned something from this video. Make sure that you write down notes and you date your notebooks. Feel free to practice on the Maths Watch and my iMaths task that I posted on Everest or I sent through email. If you have any questions, don't hesitate to send an email to me. And so let's see if we have achieved our goal for the day. So we say that we wanted to correctly draw the graph of a linear equation. In this case, we use the table method to do that, and we have achieved that, and we say that the goal has been achieved. Thank you.